Hello again, and we're going to start talking a little bit into chapter 4 in our trigonometry textbook. So far in all our trig stuff, we've kind of been working with sine and cosine and tangent. That's the big things that we've been working with. But up to this point, we've been working with specifically right triangles, and how to solve those things. So for example, something like this, right? This is what we've kind of been working with. We can use sines and cosines and tangents to do that. So if we come across this with a right angle in there, we could figure that one out, because here we could say, oh, we've got our angle, that's 50 degrees in this case. We've got x over here, something we don't know, and then this hypotenuse being 16. You can always set those things up. You guys know how to do that. It's opposite. There's a hypotenuse. We could set that up and say, oh, sine with 50 degrees, because again, as we've talked about, our angle always has to be connected with the trig function, and that should tell us, or should be equal to, a proportion or a fraction, right? X over 16, opposite over hypotenuse. And then we just go ahead and solve this. We take the 16, multiply it over here, and say it's 16 times sine of 50 degrees, and that should be x, and we can go ahead and put that, in our calculator, type that in and get how big that is. It's not too bad to do. But what we're going to talk about today a little bit is, what do we do if the triangle is not a right triangle anymore? So in this one here, might be a little bit tough to see on your screens there, but we've got this kind of short side here is 16. Again, I just used the same thing. And here I just made this angle about 30 degrees, and this one's 100 degrees. Can we figure out the rest of that? And the answer is yes, we can, but we need to utilize something a little different. We can't just use sine or cosine or tangent. You can only use sine, cosine, or tangent on their own if you have a right triangle. If you don't have a right triangle, then we have to utilize something different. And so that's what we're going to go over here. We're going to go over the law of sines today, and that is when we don't have a right triangle. The other one that we'll end up learning about in a bit, that's the law of cosines, is another one that's able to be used. And to my knowledge, I don't know if there's one for a law of tangents, because the law of sines and the law of cosines cover anything that you'll need to know, so you won't need anything different there. But the law of sines here has a little bit of a formula to it. I'm going to write that up. If you want to see why it works, you can watch the other video on that. I suggest doing that. There is a reason for why the formula looks the way it does, right? But how the law of sines works, right? There's an equation for it. And what that equation is, it looks like this. We'd say little a over sine of capital A, right? This proportion always holds, right? Side over sine of the angle always holds. And so if you look it up online or in your textbook, they'll write down other stuff, but it's always paired with a small letter, capital letter underneath with the sign, right? Small letter, capital letter. When you use the letter C, sometimes it's tough to tell whether that's a lowercase or a capital letter there. But the reason for this notation, it's very specific. And what that means is any capital letters always represent vertices, or in our case, angles, around a triangle. So I could set this as capital A, capital B, capital C. Capital letters always represent the vertices. Lowercase letters represent the sides across from those vertexes. So here, if I want to find where lowercase a is, it's going to be across from capital A. So I go here and go across the triangle. 16, that is side lowercase a, right? That's lowercase a. Lowercase c is across from capital C. Lowercase b across from capital B. And that's kind of the main notation that's used with triangles, just to keep track of things, so that we can keep, have everything in order. And so then we can use this equation to set stuff up. If we've got multiple angles here, we can figure out other angles. We can actually set up two different equations here and solve either one of them. It's fine. So first up, I'm just going to take the setup that we have here, okay? So first thing here, what this always reads, side, angle across from it. So in here, I've got a side that's 16, and I have an angle across from 16 that I know. These two are known. I have that definite pair. So I'm going to put those two together. I've got 16 here, and that is across from the sine of 30 degrees, right? Because 16 is across from 30, 16 is across from 30 in my equation. That's where they go, right? And then I'm just going to set up that proportion. That proportion has to hold for any other side and angle also. So then I just have to pick one, right? I'm going to pick these two guys here because they're across from each other. And I know this one's 100. So 100 is across from B, right? That's there. So I'm going to say, well, I don't know this one. Fine. I'll write it down, right? We're in trigonometry, we've had algebra. Just write down, lowercase b is across from sine of 100, right? 100 degrees. And there we go, right? We have a setup here now using this law of sines. And we can, multiply everything across and figure it out. And in here, it's just a little bit of algebra, right? All this is a proportion. The only thing we don't know is b. That's the only thing. So here we just, cross multiply or however you want to put it, right? Essentially, I like to think about it. This is on the denominator here. We'll multiply this over to this side here. Just take these two times each other, divide by sine of 30, and put that in your calculator, and we're done, right? I don't expect you to do any of this stuff without a calculator, right? I mean, sine of 30 I know is 1/2. But beyond that, we wouldn't necessarily know those. And now we just grab, again, I'm just going to grab a calculator here and see what we get on there. Again, you can type, if you got a nice calculator, you can type the whole thing in all at once, right? We're going to take here, in this case here, we'll get in there, I got 16 times sine of 100, right, divided by sine of 30. And I would just type that whole thing in there, right there. That's just what I did, all the way across. That's just typing that in there, and then you just hit enter on that case, and we can tell that side B has to be 31.51, whatever units, right? And again, this is an example, could be feet, inches, miles, maybe if we're working somewhere. But that's what we get. We get B is equal to 31.51, units or whatever we have here, right? And then we could say, well, the triangle's almost all solved, right? If we're solving a triangle as you have in your homework, what that would mean is we got to get every single piece, right? All the angles, all the sides. Right now we got 2 sides and 2 angles. You can figure out the rest of them. Third angle is pretty easy to figure out because we know inside of a triangle has to make up 180 total degrees. So in here it would have to be 50 degrees left for that angle, right? Take 180 minus 100 minus 30. We got 50 degrees left, which then means we can set up another equation to figure out the lowercase c. We can go back to the law of sines and figure that out again. In here, there's 2 different setups that we can use, right? I'm going to show you both of them, and I'm going to tell you one's better than the other, right? It's not that you can't use them, it's just one's a little bit better. So we can go back to here again. For law of sines, we need to have a side and the angle across from it, right? So in here, I've got c. That's what I want to know. So I would put down c over sine of 50 because that's the one across from it. And that is equal to, and then I can actually pair anything because I've got this 16 and sine of 30 like we used before, right? So we could write that down, 60 and sine of 30 degrees, right? We could put that one down. That's completely okay. Again, another proportion, multiply this over, and we've got side C. If you didn't want to use that, a second way we could do this, we're still looking for side C, so we have to use that. But you could also use this one, since we now know what B is. You could do this, 31.51 over sine of 100 degrees, right? That's okay to use as well. You can use this one also, and then just multiply this over, and we're good to go, right? But one of these two is a little bit better than the other one. They're both perfectly fine. They're both perfectly usable. But this top one is a little bit better, right? I would suggest using this one. The reason being is that this one, I know this side is exactly 16. There's no rounding in this setup. Nothing has been rounded in there. We're going to have to round the answer when we get there for side C, but there's no rounding there. In the second one, there's a little bit of rounding, right? This 31.51, remember, we rounded this. So we rounded this answer, that means C is also going to be rounded, and all that rounding kind of compounds. So whenever you can use something that you didn't round, or you didn't, truncate some of the decimal points off there, that's a better option to go with most of the time, right? You're going to have more accurate numbers on there when you get your result. And so again, just to show you that those two things work out, in this one here, we multiply the sine of 50 over, right? So in there, I'd take sine of 50 times 16 and then divide by the sine of 30, right? And so that one, we end up with that being 24.51. That's side C, right? We solve that whole thing there. If we use the second one, just to show you that you get a very, very similar answer on there, we do the same thing. Sine of 50, multiply that over to the other side here. What do we got? 31.51 divided by sine of 100, right? We get almost the same thing, almost the same result. This second one here, though, is rounded a little bit more than the top one. That's why they're not exactly the same, although they're close, but that's because that 31.5 is a little bit of a different rounded piece there, right? So in this case here, if you have a couple of angles, you can use the law of sines. And what we're going to talk about in a different video, that's what if we have two sides and one angle, right? How do we do that? And so that we'll talk about next. But this is a very, very useful one, which you'll see in, maybe thinking back to geometry when you were proving triangles and things like that. Some people have different ways to call this. We knew angle, angle, and a side. So some people call that angle, angle, side. This method will also work for angle, side angle, or side angle, angle. To me, all of these are the same thing. I don't categorize them as different types, right? These are all categorized for myself as angle, 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 side. Because in all honesty, if you know two angles at any given time, you can just figure out the third one. So it doesn't really matter. So as long as you have two angles and a side, technically, you can figure out the third angle. So if you have your angles and a side, the law of sines works perfectly. There's no adjustments that we have to make. Although if we have a different type of one, which we'll talk about in the other video, I'll talk about that. What happens if we have two sides and an angle? What do we do in that case?